what do you find as the most difficult challenges you face on projects when trying to propose innovative low-energy concepts? And where do you find most of the barriers? Is it the architects, the developers, or even is it the cost planners or the quantity surveyors? Perhaps Mehdi to start with.
The barriers are generally, for most buildings, first barrier is the cost. That needs to be balanced, and you need to be able to have a cost benefit to the project for any type of innovative solutions. For super tall buildings, we generally look at implementing solutions that are adaptable to the architecture and the rest of the systems, because as I indicated in my presentation, most of these buildings are designed as iconic type of buildings. They need to blend themselves with the solutions that are not as harsh to what the objective of the project is. So there are several pressures or points on the solutions, but if you go through an integrated process by sitting down and having an understanding of all aspects of the project, you can come up with solutions that are adaptable to it.
Because design tall building is all design profession would like to do something interesting, but overall it's the integration consensus among all parties, the architects, the structural engineer, the owners, and then cost is an obvious factor, but it all depends on what the client wants, and then based on its vision, whether we want a grade A, because it can be grade A building, could be grade AA building, it can be grade AAA building, All these affect the cost. You have to ask the owner, and then based on the owner views, and then you can innovate or interactive. And also innovation is no one party's work. It's totally cooperation among all professional bodies.
I think the most important thing is in the owner of the building. The owner makes the final decision because he knows exactly what he wants. He has certain requirements, and so he pretty much determines everything. And the designer will try to design according to the owner's wishes. Also, it's limited by the technology and also limited by the development of the materials and building technologies. But overall, you have to optimize every factor. That's all I can say.
Hello there. Good afternoon. I'm most interested by your presentations, but earlier on I listened to one from WSP on the San Francisco Tower. And I'm just interested to know to what extent you've experienced using underfloor air systems in these tall buildings and any impacts on wind pressures and issues associated with plenum systems rather than ducted systems.
I've worked on several high-rise buildings with underfloor, not necessarily super tall. As I indicated in my presentation, most super tall buildings are mixed-use occupancies with office area at the lower part of the building, and then the rest is usually hotel or other residential arrangements where underfloor is not really applicable to them. However, in our experience with the high-rise buildings and underfloor, there are critical aspects of this that needs to be looked at, especially from workmanship and the construction of the floor, leakages and other arrangements. But generally, they have performed very well. We have a project that we did in Korea that's operational now. It's a 50-story office building, completely underfloor, and it's been well received and performed very well. It's the project that received the highest grade of energy award in Korea, which is grade 1, one of the first ones that received that through an independent study. The concept that we utilize is a very simple, what we call air column design, where the mixing unit is at the core. We make the primary system very cold, so you deliver cold air into the floor level, which makes the system very small, very compact. And then at the floor level, you take the heat from the lights and occupants and use that to reheat the air to push it into the raised floor. So it makes it very economical. It gives local heat recovery arrangement. And it's been very successful. There are a lot of them that are installed in cold climates and other climates.